Welcome to this version of the FDTD Satellite Applications webinar. Today, we're very happy to have Matt Reagan and Brendan Shaper from the Forecast Office in Nashville, and they'll be talking about the operational review of the historic Waverly, Tennessee flash flooding that occurred last month. This is part of an ongoing series of webinars that are led by National Weather Service forecasters. Dan Bykos and I'm Scott Lindstrom, are always looking for speakers. So if you know someone who wants to speak on a topic, or you want to volunteer something, you want to volunteer yourself, please contact us about the event you want to talk about, and we can help you create imagery if you need it and guide you through this. It's a pretty simple process. And there is a website there that has all the past webinars, links to the past webinars, which are recorded, and you can view the PowerPoint presentations as well. Just some protocol quickly, about 20 minutes for the speaker. You can send questions via GoToChat, or you can ask during the question and answer period via phone. So we'll be done by 18:30. There'll be Q&A. That's why we need the questions. Don't press hold, mute when you're not speaking, and take it away, Matt. Thanks.
Thank you, Scott, and thank you, Dan, for inviting us. Let's see here. Scott, do you need to make me the presenter?
Okay, let me, okay, change presenter to Matt. I didn't realize I had to do that.
All right. Is that showing up?
Yes, it is. It's
okay.
Yes.
Okay, well, we appreciate the opportunity to speak about this event, which made national news, obviously. This occurred 1 month and 1 day ago, so it's still fresh on the minds here in Middle Tennessee. And it just was a devastating event for a small town toward the Tennessee River. So what I'll do is I'm going to start with the setup, and then we'll go over the event itself and what ended up happening. This was a kind of a classic Maddox frontal pattern setup, and so we'll kind of go through it that way. First thing that we're looking for is mid-level ridging, which you can see the axis there west of Tennessee over toward Arkansas, Missouri, and a few subtle short waves in that flow. We have upper low to the east of our area, and you can see that's Hurricane Henri making its way toward the northeast. But those little subtle short waves did provide a lift as they rode on the east side of that mid-level ridge. Looking down toward the low levels, we did have convergence in the area of interest there, which again is kind of the western Middle Tennessee. The 850 flow wasn't all that strong, but it was 20, 15 knots converging there along the Tennessee River. Now, we definitely had an exceptional moisture profile in place. I have to thank Scott Lindstrom for saving these loops from GOES 16. So here we're looking at total precipitable water, and you can see again kind of along the Tennessee River, which separates West and Middle Tennessee. Precipitable water is above 2 inches. As you go east, there's quite a gradient on the eastern part of our CWA. We're less than 1.5 inches. So there's definitely a boundary there with, again, really exceptional precipitable water values in West Tennessee and right along the Tennessee River. The 12Z sounding here at OHX did confirm that with a precipitable water of 237, which looking at the sounding climatology is well above the daily max. Other things that we're looking at, our warm cloud depth was more than sufficient, almost 15,000 feet, and we were saturated to above 500 millibars. So quite the efficient sounding for heavy rain and warm rain processes. So the next thing that we looked at here is the boundary that I mentioned before, draped, again, kind of over western middle Tennessee, and it goes upward into far western Kentucky, southern Illinois. This is your low-level water vapor, where you can make out the dry air east, kind of in our eastern part of the CWA, with a more moist air to the west, and you can see the development of convection right along that boundary. Looking at the layered precipitable water, that boundary again can be made out. If you look at the top left panel, that is your layered precipitable water from the surface to 850. That boundary can be noted there, again, over western middle Tennessee, going into even northern Alabama and northward into western Kentucky. One thing to note as you go up, looking at 700 to 500 and 500 to 300, our moisture source was actually coming from the Pacific, where our low-level moisture was coming off the Gulf of Mexico. Looking at the OBS, you can draw the stationary boundary right across the western part of our area. While it wasn't a huge difference in temperature or even dew points, again, that the overall moisture gradient was quite impressive from West Tennessee into the eastern part of our area. Now, looking at the storm motions, and I did this by looking at the derived winds here off GO 16, you will see that we are paralleling that boundary. So ample opportunity for training storms with that moisture feed from west to east with that convergent 850 flow, and impressive moisture content west of that boundary set us up kind of that fire hose event there right over the western part of our warning area. So how did the models handle this leading up to it? I'm going to hand it over to Brendan to explain that.
Thank you, Matt. Now that we've seen some of the overall setup, diving into some of the model performance, Matt was on the evening shift. I was on the day shift on a Friday, the day before the actual event. And some of the CAMS models, convective allowing models, showed that the rainfall axis was starting to appear basically along and west of Interstate 65 in Middle Tennessee on things like the HRRR, the NAM 3-kilometer, and we'll show those here in just a moment. But sort of the progression of the every 6-hourly HRRR models, you see the 18Z run on Friday was showing a pretty good axis there of upwards of 6 to even close to 8 inches in some pockets there west of the Nashville metro. And then as we went forward in time, 6 hours there to the 0Z run around 7 p.m. Friday on the evening shift, you can see that axis still showing up in the HRRR, and then 6Z, the model came in and it showed a little bit less in terms of the magnitude of the rainfall totals. So progressively, as we went through the afternoon and evening on Friday, there was quite an eye-catching signal earlier in the day. And as time went on, the HRRR actually pulled back a little bit on the magnitude of the rainfall. The HREF, showing the max composite values from all of its suite models, showing kind of the axis there running along the Tennessee River from southwestern Kentucky through western middle Tennessee. Some values in there reaching the 7 to 10 inch range, highlighting that the magnitude of this event could be significant, especially over the period of time that we were looking for, which was mainly during the morning hours of Saturday. The NAM 3-kilometer, again, sort of a 6-hourly progression from kind of the top of the 6-hour runs. You'll see there on Friday afternoon, the NAM was showing, again, signs of upwards of 6, 7, 8 inches in some places, reaching from the Boot Heel of Missouri all the way down into western middle Tennessee. And notice too, of course, we tried to pick the same, close to the same spots on each of these maps to highlight sort of the the ranges of total rainfall, and you'll see 7.7 on the far left image. Then we went to the 0Z run, a little less there, and then finally by the 6Z NAM run Saturday morning, 6.5 inches. So models were pulling back ever so slightly, but that axis of heavy rainfall was still present in some of the CAM's guidance. Now the global models were a little bit of a different story. The GFS there on the bottom left, the 0Z run, showing an axis west of Middle Tennessee, sort of positioned over the Memphis area, a little bit farther west. The European run at the 0Z time step there, showing that axis again, sort of centered over the western Middle Tennessee counties, a little bit farther east, sort of where it's set up. So the area, the geographical space was actually decent on the global models, except the magnitude was quite low. Some of those images there, the GFS showing 1.3 in the bullseye of some of those precip returns, and then upwards of 3 inches along the Tennessee-Kentucky line. So 1 to 3 inches in the global models didn't really help us pinpoint the magnitude of the event quite well, but the geographic space was sort of centered in the same area as the CAM guidance. And then the European ensembles, you see there the PWatt values basically maxed out on the top right-hand corner of the image, as well as the vapor transport. So we knew that there was going to be ample moisture available in this location. So let's talk a little bit about the timeline, and we'll go through some of the products that were issued as well. We'll start with Friday afternoon. Again, Matt was on the evening shift, I was on the day shift, and as we were kind of handing things off, the public messaging quickly increased later in the afternoon to highlight that we were starting to see CAM's model showing 6, 7, 8 inches in a pretty short time span of 6 to 8 hours Saturday morning. So we quickly ramped up kind of the Twitter and the Facebook messaging, as well as messaging to our partners. And the evening shift took it from there with a run-to-run consistency in the CAM's guidance of high rainfall totals, kind of over a consistent area, led to the issuance of a flash flood watch. What's important about that is that they went ahead and tried to issue that prior to our local 5 o'clock newscast, so that the broadcast meteorologists in the news would have ample information to get it out to the public as efficiently as possible. So that was Friday afternoon. We noticed that increasing flash flood threat, and then overnight we expected the rain to start shortly after midnight, and it did. This is a WPC mesoscale precipitation discussion, kind of highlighting that similar area that we were seeing in the models over western Middle Tennessee, where that stationary boundary was focused. Notice a little bit of a strengthening low-level jet that they highlighted as well in their image. And I highlighted some of their text from their discussion, basically saying the same thing, where they were seeing an elevated stationary front with an increase in warm air advection and deeper moisture that could allow rainfall rates to reach or exceed 2 inches per hour. And the expectation was that some spots could reach 3 to 4 inches or more for this particular time frame. This is a loop here of basically the entire rain event, but you'll see kind of that axis of heavy rainfall set up across western Middle Tennessee. When the rain began, it started just before 1 a.m. and rainfall estimates were around 1.5 to 2.5 inches by 3:15 in the morning. So it had been raining for about 2 hours, and the rain that was calculated there roughly fell between 1.5 and 2.5 inches. The first flash flood warning was issued at 3:29 a.m. So it kind of caught the flash flood guidance there at about the 2 to 2.5 inch range. MRMS did a really spectacular job with this event in terms of its spatial coverage and the magnitude with which it depicted the rainfall. So the heaviest rain really occurred between 11Z and 14Z. The heaviest amounts were just east of a town called Waverly that we're kind of honing in on in this discussion. The MRMS estimated 1 hour rainfall amounts were up to as much as 4 inches. So think of a 4 inch per hour rainfall rate early in the morning. Luckily, this was a Saturday morning, so you didn't have the weekday rush hour, but that's quite a bit of rainfall in a short amount of time. CREST unit Streamflow also gave us some clues about where the heaviest rainfall was located and how it was draining throughout the basins west of Nashville. It really did do a good job of depicting the high stream flows and, of course, the flash flooding that followed pretty quickly, that heavy rainfall, as we approached the sunrise hour on Saturday. Here's a little bit closer look at Waverly and the surrounding towns. You'll notice Dixon to the east along 70, Hurricane Mills just to the south of Waverly. But this is really to highlight sort of how that heavy rainfall from the east of Waverly drained westward through Trace Creek into town, into Waverly proper. And that really caused significant catastrophic issues there in the town of Waverly. This was an image that was posted just before 8 o'clock on Saturday morning, highlighting the flash flood emergency that had been issued at 7:47 a.m. Prior to that, the first flash flood warning that was issued shortly after 3 a.m. had been upgraded already to a considerable flash flood warning and set off the wireless emergency alerts. But at this point, we were receiving reports of water rescues and a lot of issues out here in western Middle Tennessee, and heavy rain was only increasing in intensity and coverage, with MRMS rainfall rates reaching, of course, 3 to 4 inch per hour rate around sunrise Saturday. By 7 o'clock, an estimated 3 to 9 inches had fallen over this particular area, and it was really a 4-county area from Houston, Humphreys, Dixon, and over to Hickman counties. So this flash flood emergency was coordinated after talking with emergency management and hearing about life-threatening flooding happening in these areas. I'll let Matt take it over from here to talk about the event conclusion.
Okay, it was quite an exceptional period of rain rates and rain amounts. You can see rainfall totals observed in McEwen at the co-op station of over 17 inches. And you know, that's the one that we've been focusing on, and they're reviewing it. Once it is confirmed, it would be a state record for a 24-hour rainfall amount, which previously was a little over 13 inches. So not only did it break it, it busted it. But you can see quite a few reports there of over 5 inches of rain for that 24-hour period. Again, the heaviest rain actually fell east of Waverly and then drained westward, but there's quite an area of over 10 inches where that flash flood emergency was issued. The Piney River in Vernon is located southeast of Waverly towards Centerville. It broke its record CREST, which was 32.78 feet. Major flood stage is 24 feet, so it broke it by almost 9 feet. The Duck River is the larger river that runs through the western part there. It wasn't quite as high as May 2010, which is the big Middle Tennessee flood that everybody remembers that flooded Nashville. This was more of a localized event, but a much more intense event. So some of the images of the devastation. Luckily, this was a Saturday morning because the Waverly school systems, the elementary school, middle, and high school, were all flooded with up to 4 feet of water in them. So we were very fortunate that it was a Saturday and not during the week. You see there a little video of the actual flooding in Waverly. Also, I found this pretty sad. This was one of our co-op observers that after 5,000 reports, it would be the last one from the station that the flood took the deck and the rain gauge down the river and then destroyed the house. So very sad story there as well. Now, we got eyewitness accounts of what people described as a mini tsunami or a flood wave, where it almost sounded like they were describing some sort of dam break or levee failure. But we do not have a dam upstream of Waverly, and we don't have any levees that we were aware of. This video was then posted a few days later or a week later, showing how rapidly the water rose around 10 a.m. This time lapse is a matter of about 10 minutes. So before you could see just a little water in the street to begin with, and then 10 minutes later, a raging torrent of water flowing through the town and eventually sweeping cars and structures away. So there is first of all, let me show you the MRMS data from 10 o'clock that morning. So the 1 hour QPE, that should say over there on the left, the heaviest rain had already fallen and actually had moved south of the heaviest hit area. The CREST stream flow was obviously still very elevated with all that water. But as far as the most intense rain, it had been over for a couple of hours. So the theory that's being contemplated right now is that perhaps the railroad tracks east of town acted like a levee. So a couple things to note here: there is a railroad bridge circled there that goes under the highway, and that's Trace Creek that goes under it. This area to the north over here on the left picture and to the right here on the right, that's where Trace Creek is. That is a flatter area where perhaps water could build up. So if you had enough debris that could possibly clog up and slow the flow underneath the railroad bridge, it is possible that you could build water up in this area, again, upstream of that bridge and upstream of Waverly. Looking at the slope data and the elevation, the railroad bridge is anywhere from 13 to 20 feet higher than the creek. And again, if you can block up the railroad bridge, this could perhaps act like a levee, that is the railroad tracks. There is evidence in the aftermath of where the railroad tracks and the earth underneath it actually washed away, again, almost acting like a levee failure and perhaps letting that flood wave come into the town of Waverly, which is when most of the destruction actually occurred. So just to wrap things up, unfortunately, we did have 20 fatalities with this event. 19 of them were in Waverly. One is in Hurricane Mills, which is west of Waverly, still in Humphreys County. This is the deadliest flash flood event we've had in our warning area for a single day. The May 2010 event, which again has been the marker for flood events here, had 22 fatalities across the state, and that was over 3 days. We are reviewing the rainfall amount in McEwen to confirm that it did indeed break the single day record for rainfall in Tennessee. MRMS was a huge help in this event. Both the QPE was pretty accurate, and the CREST was a great guide as far as drawing up the polygons and remembering to give yourself enough buffers to include those basins where the water will flow, not just where the rain is falling. But peak rain, 1 hour rainfall amount, we had 4.29 inches based on observations, and peak 3 hour rain amount of 10.92 inches measured between 4:40 and 7:40 a.m. The cams did a good job signaling the area for the event and that a significant event could occur, but still it was obviously not quite picking up the magnitude of the significance of this event. The global models kind of had the area okay, but as far as amounts were obviously too low. I'll end here with this depth, duration, frequency from the stage 4 precip data from McEwen, just to kind of give you an idea of the significance of the event. The red was the observed rainfall, and you're looking at return intervals for those durations, and it's just off the charts, unbelievable. So quite an unspeakable event here that devastated the town of Waverly. Brendan has put together a GIS story map for this. There will be a link in the presentation, so you can click on that. You can also go to weather.gov/Nashville, and there's a headline where you can click to go to that and view some of the images and some of the overview of the event. That is all I have. I know we probably went over a little bit, but we'll be happy to take any questions that anybody might have.
Thank you. That was awesome. So is McEwen, Tennessee? So Waverly is downriver from where McEwen is. I guess that's my question.
That is correct.
Okay.
In fact, McEwen is about 250 feet higher than Waverly, so there's actually quite a elevation difference, and it's about 10 miles to the east upstream of Waverly.
Okay. We do have a question from Vanessa. How was the satellite imagery useful for monitoring the weather activity? So as the rain was falling, I'm guessing, were you focusing mainly on satellite imagery, or was it more of a radar thing?
I would say both. The radar imagery, you know, again, MRMS was extremely valuable, but also monitoring the satellite data, just looking at cloud tops, making, you know, seeing that convection just was not weakening and kept developing, you know, along that stationary boundary.
And Vanessa also had the question, can you use satellite imagery to determine if a front is likely to become stationary?
That I'm not sure. Brendan, I don't know if you have any suggestions on that.
I would just say we monitored satellite data through the day, because we actually did have a second wave of rainfall, albeit not as impressive as the first wave in the morning. We were monitoring satellite to kind of see where that gradient of deeper moisture and subsequent stationary boundary was, to see if that would shift a little bit east or west through the day, because models were suggesting that the heavier rainfall in the afternoon and evening would slide a little bit east of where the heaviest rainfall was in the morning. So not sure if you can kind of anticipate it to stay where it is, but you can anticipate kind of where it's going through the day.
Yeah, I will say you could, I guess, monitor water vapor to see, again, if you have, I guess, a larger scale trough coming through that might kick the front out finally. But that wasn't really the setup that we had in this case.
Yeah. And I would say, yeah, if you're using where the convection is forming upstream, if the source region is not really changing, that would convince me that the front's not really moving too.
Yeah.
But yeah. We have a comment here from Sheldon. One of the unique aspects of an event like this is the depth of the moisture, and it's being replenished, and you can see that with the precipitable water products that are generated from the microwave imagery versus the GOES imagery, which you lose information where the clouds are.
Yeah.
Right, so you can just see it, the moisture just keeps coming.
Yeah, I mean, again, that day, I mean, the moisture profiles and, I mean, were just unbelievable, and the rainfall efficiency that we had.
Well, I don't see any other questions. Oops, in the upper level from the southwest and then northwest, and low levels from Texas and beyond. Okay, so the moisture is coming in the upper levels from the northwest and the from the southwest and then northwest at low levels. Okay. I'm mindful of the time. It's almost 18:30 UTC. So I don't see any other questions that have come in. I really want to thank Matt and Brendan for their talk and their willingness to give the talk. So thank you, and that concludes this webinar.